This is Chapter 5, Part 1 of the Cloud Computing video. This chapter covers safety and disaster protection in cloud environments. In this part of the video, we will focus on Section 5.1, Security Aspects in Cloud Computing, and Section 5.2, Security Issues in the Cloud Computing Model. Section 5.1 focuses on 5 key security aspects in cloud computing: identity and access control, network security, data protection, encryption, and monitoring and logging. This slide explains why cloud security matters. In the cloud context, your apps and files are stored on the cloud provider's computers, not on your own device. Because of this, security becomes very important. The core purpose is CIA. CIA means confidentiality, integrity, and availability. Confidentiality means data stays private. Integrity means data stays correct. Availability means data is available when you need it. Good security also gives operational value, keeping users safe while the system stays fast and smooth. But there are potential risks. Attackers might read your data, change it, or stop the system, for example, breaking into a cloud storage account. The CIA triad is a simple way to understand cloud security. C means confidentiality. Only authorized people can see the data, using passwords, encryption, and access control. I means integrity. Data must stay correct and not changed without permission. Tools like hashing, digital signatures, and audit logs help with this. Hashing creates a digital fingerprint of data, and audit logs record who accessed or changed the system. A means availability. Systems and data must be accessible when needed, using backups, redundant servers, and DDoS protection, which prevents attackers from overwhelming the system with too many requests. The shared responsibility model means cloud security is shared between the provider and you. First, let's look at what the cloud provider secures, called security of the cloud. The provider protects the data centers, including buildings, power, and cooling. They also manage physical servers and storage, network hardware, and core cloud services. As users, you do not control these. Next is what you secure, called security in the cloud. You are responsible for account settings and configurations, user accounts and permissions using IAM, identity and access management, virtual machines, applications and databases, and also your data and backups. In other words, you are responsible for these. Your responsibility also changes based on the service model. In IaaS, you manage most things like virtual machines, network, and operating systems. In PaaS, you mainly manage applications and data. In SaaS, you mostly manage users and data only. For example, if a company uses Google Drive, Google secures the servers and infrastructure, but the company must control who can access the files and how the data is shared. Identity and access management, or IAM, controls who can log in and what they can do in a cloud system. First is control identity, meaning who can log in. The purpose is to make sure only real users can access the system. We use user accounts instead of shared accounts, require strong authentication, and verify identity before any access is given. Next is control permissions, which defines what users can do. Access should be assigned using roles, and we follow the least privilege principle, giving only the minimum access needed. The third part is protect high-risk access, especially for admin and production systems. This includes enabling MFA for admin accounts. MFA means multi-factor authentication, which requires more than one verification step, such as a password and a code sent to your phone. The key idea is, the right user gets the right access at the right time, with minimum risk. Network security in the cloud focuses on protecting how systems connect and communicate. First, create a private network, such as a VPC or VNet. VPC means virtual private cloud, which is your own isolated network inside the cloud provider's environment. Inside this network, you can use subnets to separate systems and apply firewalls or security groups to control who can connect. Second, reduce exposure to the internet. Try to avoid giving servers public IP addresses. Instead, use private endpoints for internal access only. When there are fewer public services, there are fewer attack targets. Third, separate environments. Keep development, testing, and production in different networks. This way, mistakes or attacks in dev or test will not affect production systems. For example, a company running a cloud application may keep its database in a private subnet without a public IP, so only the application server can access it. The key idea is that cloud networks should be private, restricted, and separated to reduce attacks and limit damage. Data protection focuses on keeping cloud data safe in different situations. First, encrypt data in movement. This means protecting data while it is traveling across networks. We use TLS or HTTPS for this. TLS means Transport Layer Security, a technology that encrypts data during transmission. HTTPS means Hypertext Transfer Protocol Secure, which is the secure version of HTTP used by websites. For example, when you log into a cloud system and see HTTPS in the browser, your username and password are encrypted while moving across the internet. Second, encrypt stored data, also called data at rest. This means locking saved data using encryption. This protection applies to disks, backups, and databases. So even if someone accesses the storage, the data remains unreadable without the encryption key. Third, rotate and manage keys. Encryption keys should be changed regularly, usually every few months, and systems should keep usage records to track how the keys are used. The key idea is to protect data in movement, protect data at rest, and classify data by sensitivity. For example, public data is for everyone, internal data is for your team, and confidential data contains sensitive information that needs stronger protection. Logging, monitoring, and alerts help cloud systems detect problems early and protect services. First is collect. Systems collect logs, which are records of events such as logins, errors, and changes. They also collect metrics, which are numbers showing system performance like CPU, memory, and requests. Another type is traces, which show the path of a request across services in the system. Second is alert. Alerts help detect problems quickly. For example, the system may detect many errors suddenly, repeated failed logins, or unusual traffic from strange locations. The purpose is to know something is wrong immediately, so action can be taken. Third is protect. Logs should be immutable, meaning they cannot be changed or deleted, and they should be kept for a retention period, such as weeks or months. This helps with investigations and audits. For example, in a cloud web application, monitoring may detect many failed login attempts from another country, and the system immediately sends an alert to the administrator. The key idea is simple. Logs show what happened, monitoring shows system health, alerts warn you early, and log retention provides proof. Backup, disaster recovery, and resilience help cloud systems continue running even when problems happen. First, why this matters. Systems can fail because of human mistakes, hardware failure, cyber attacks, or natural disasters. Without preparation, data and services can be lost. In cloud environments, failures may happen suddenly, so recovery planning is important. Next is what to do. One key practice is regular backups, which means saving copies of data often. Another important step is to test restore, to make sure the backups actually work when needed. Another method is to use multiple locations. Cloud systems can run in more than one availability zone or region. If one place fails, another system can continue running. For example, a cloud website may run in 2 regions, so users can still access it if one data center stops working. We also need to set recovery targets. RTO, or Recovery Time Objective, means how long the system can be down before it must recover. RPO, or Recovery Point Objective, means how much data loss is acceptable. For example, a company may set 1 hour maximum downtime and 15 minutes maximum data loss. The key idea is simple. Failures happen. Backups save data. Recovery restores systems. Resilience keeps services running. Compliance and governance mean making sure a cloud system follows the law, rules, and company policies. First is rules. Organizations must know the rules and understand laws such as PDPA, ISO, and HIPAA. PDPA means Personal Data Protection Act, which protects people's personal information. ISO refers to international security standards, such as ISO 27001 for Information Security Management. HIPAA means Health Insurance Portability and Accountability Act, a law that protects medical and health data. Companies must know what data is allowed and how to protect it. Second is controls. Controls help prevent mistakes using guardrails. These guardrails use policies and rules to prevent risky configurations. For example, a cloud policy may block public storage or prevent weak passwords. Third is proof. Organizations must be able to prove compliance. This is done by keeping audit logs, generating reports, and saving evidence. These records help during inspections or security reviews. The key idea is simple. Compliance means follow the rules. Governance means enforce the rules. Audits mean proving that the rules were followed. The goal is simple. Get good security without wasting money? First, use managed cloud services. Cloud providers already include security features such as patching, backups, and monitoring, so it is cheaper and safer than building everything yourself. Second, start with free or low-cost basics. Always enable MFA to protect accounts, TLS or HTTPS to protect data in transit, and logging to detect attacks or mistakes. Third, protect the most important systems first, such as databases with personal data, payment systems, and core business applications. The key idea is, Secure the most important things first using built-in, low-cost tools before expensive solutions. In summary, cloud security involves people, process, and technology. Focus on identity and access management, network, data, applications, and monitoring. It is essential to practice backups, disaster recovery, and governance from day one. We now move to a detailed look at security issues in the cloud computing model. Common threats include cyber attacks, data breaches, misconfiguration, insecure APIs, and account hijacking. Understanding these risks is crucial for effective cloud security. When we talk about security issues in cloud computing, we are often talking about mistakes, risks, and their impact on CIA. First is mistake. Many problems happen because of configuration mistakes, meaning wrong settings in the system, not advanced hacking. For example, a cloud storage bucket may be set as public by mistake, allowing anyone on the internet to see the data. These mistakes create risk. The risk affects the CIA triad, which means confidentiality, integrity, and availability. Data may be exposed, changed, or systems may stop working if settings are wrong. These issues apply to all cloud models, including SaaS, PaaS, and IaaS. The key idea to remember is simple. Most cloud security problems come from mistakes, not attackers. In software as a service, users access applications through the internet, so several security issues can happen. One common problem is account takeover. If users have weak passwords or no MFA, attackers may log in to the account. Another issue is data leakage. This happens when files are shared with the wrong people, or when public links are used carelessly. We may also see shadow IT, where users sign up for online tools without approval or visibility from the organization. This can create security risks because the system is not monitored. To reduce these risks, organizations can use SSO and MFA, which provide strong login control for all users. SSO means single sign-on, allowing users to log in once to access multiple systems, while MFA means multi-factor authentication, requiring more than one verification method. Another protection is DLP policies, where DLP means data loss prevention. These policies help prevent sensitive data from being shared incorrectly. Organizations should also set clear sharing rules, defining who can share data and with whom, and use audit logs to track user actions and detect misuse early. For example, in a cloud service like Google Workspace or Microsoft 365, administrators can control file sharing and monitor activity through audit logs. The key idea is simple. Protect accounts, control sharing, and monitor user activity. In Platform as a Service, developers build and run applications on cloud platforms, but some security issues can still happen. One problem is APIs exposed to the internet. If an API has no login or no rate limits, attackers may abuse it by sending too many requests. Another issue is secrets stored unsafely. Sometimes keys or passwords are written directly in the code, or accidentally pushed to public repositories. We may also see risky software dependencies. Applications often use external libraries, and some libraries may contain known vulnerabilities. To reduce these risks, we can use private endpoints, so APIs are not directly reachable from the internet. Another solution is a secret manager, which stores keys and passwords securely, instead of hard-coding them in code. We can also use a web application firewall, or WAF, which blocks common attacks on APIs and web applications. Finally, organizations should run security scans such as SCA or DAST. These scans detect vulnerable libraries and unsafe behavior early. For example, in Google Cloud or AWS, developers can store API keys in a secret manager service and protect the API using a WAF. The key idea is simple: protect APIs, hide secrets, and check dependencies regularly. In infrastructure as a service, users manage servers, storage, and networks in the cloud, so configuration mistakes can create security risks. One common issue is storage buckets left open to the internet. This means anyone can view or download the data if the storage is set as public. Another problem is over-permissive security rules, such as 0.0.0.0/0. This rule means servers are open to everyone, everywhere, which can expose systems to attacks. There can also be unpatched virtual machines. An unpatched virtual machine means a server that has not installed the latest security updates or fixes, so it may still contain known security holes. To reduce these risks, organizations use bucket policies and IAM, which control who can access storage and what they can do. They also apply least privilege security rules, meaning only required ports are open to specific IP addresses. Another protection is using patch baselines and golden images. A patch baseline defines which security updates must be installed on servers. A golden image is a pre-configured virtual machine image that is already secure and updated, used as the standard when creating new servers. For example, In AWS or Google Cloud, administrators can launch new virtual machines from a secure golden image and apply automatic patch updates. The key idea is simple. Do not expose resources, limit access, and keep systems updated. Cloud platforms often use multi-tenant systems, meaning many users share the same cloud infrastructure. Because of this, isolation between users must be protected. One issue is the noisy neighbor problem. This happens when another user uses too many resources, such as CPU or memory, and it slows down your system. Another risk is isolation failure. This is rare, but serious. It happens when a system breaks out of its container or virtual machine and affects other users. For sensitive workloads, organizations may use dedicated resources for sensitive data, such as dedicated virtual machines or hosts for high-risk or critical data. To reduce these risks, one solution is to use managed services. The cloud provider handles isolation and security updates, reducing many technical risks. Another important step is to keep systems updated. Installing patches helps reduce known isolation weaknesses. For highly sensitive systems, companies may also use dedicated resources, which means the server is not shared with other customers. For example, a financial system storing customer data may run on dedicated cloud hosts instead of shared infrastructure. The key idea is simple. Shared systems are efficient, but isolation must always be protected. Identity and access management can create risks if it is not configured carefully. One problem is when access keys last too long and get leaked. For example, a developer may accidentally push a secret key to GitHub, and attackers could use it to access the cloud system. Another issue is admin access given directly to users or systems. If a normal user has full administrator rights, one mistake can give full control of the system. To reduce these risks, we can use short-lived credentials. This means access expires automatically after a short time, reducing the chance of misuse. Another protection is role-based access control, or RBAC. With RBAC, users and systems only receive the permissions they need, not full administrator access. Organizations should also apply key rotation, which means changing access keys regularly to reduce damage if a key is leaked. Finally, secret scanning tools can automatically detect leaked keys in code repositories. For example, in AWS or Google Cloud, developers can use temporary credentials and IAM roles instead of permanent access keys. The key idea is simple. Do not trust long-term keys. Use roles, short access, and regular checks. In cloud environments, network exposure and lateral movement can create serious security risks. One problem happens when services are accidentally exposed to the public internet. This means systems that should be private can be accessed by anyone online. Another risk is that attackers can enter one system and move to others. This movement between systems is called lateral movement. This becomes easier when organizations use flat networks, where many systems are connected without separation. In such networks, attacks can spread quickly. Also, more copies of data can increase the risk of data leaks, especially if many systems store the same information. To reduce these risks, organizations use private subnets. This keeps internal systems off the public internet. Another solution is network segmentation, sometimes called zero trust. This means splitting the network into small, isolated parts, so attacks cannot spread easily. Organizations can also use bastion access, which means a single secure entry point used to access internal servers. Finally, least privilege routing allows only necessary network traffic, reducing unnecessary connections. For example, a company may keep its database inside a private subnet, while only the web server is accessible from the internet. The key idea is simple. Hide internal systems and limit how attackers can move inside the network. In cloud systems, data risks often happen when data is not protected properly. One problem is when data is not encrypted. If someone gains access, they can read the data easily. Another issue happens when encryption keys are poorly managed or reused, which makes it easier for attackers to misuse them. There is also risk when too many data copies are stored in different regions or tools. When there are more copies of data, the risk of data leaks becomes higher. To reduce these risks, many cloud platforms enable default encryption, meaning data is automatically encrypted when it is stored or sent. Organizations also use a key management service, or KMS, where encryption keys are stored safely and changed regularly through key rotation. Another protection is data classification, which means labeling data as public, internal, or confidential, so each type receives the correct level of protection. Companies can also use data loss prevention, or DLP, which detects and blocks sensitive data from being shared incorrectly. For example, a cloud storage system may automatically encrypt files and prevent confidential documents from being shared publicly. The key idea is simple: encrypt data, control keys, and limit where data can go. Misconfiguration means wrong cloud settings that expose systems or data. Most cloud incidents happen due to misconfiguration, not hacking. Some common real cases of misconfiguration include several simple but risky mistakes. A storage bucket left public means the cloud storage is set so anyone on the internet can view or download the files. A database accessible from the internet means the database server is open to public access instead of only internal systems. Logging turned off means the system does not record events such as logins, errors, or changes, so problems cannot be traced. Test settings reused in production means development settings are used in the real system, which may be less secure. Misconfiguration also happens for several common reasons. It works in development means the system works in the dev environment, but developers may use simpler or less secure settings just to make testing easier. No proper checking before going live means the system is launched without reviewing security settings, such as access rules, encryption, or logging. Settings copied without review means dev settings are directly copied to prod. Development systems often allow public access, weak passwords, or open ports for testing. If these same settings are used in production, the system or data may become visible to the internet or accessible to unauthorized users. Misconfiguration can cause several serious impacts. Data leaks happen when cloud storage or databases are exposed. This means unauthorized people can see or download sensitive information, such as customer records or company files. Security breaches occur when attackers gain access to the system because of weak or open settings, allowing them to steal, change, or damage data. No logs to trace problems means the system does not record events like logins, errors, or changes, so administrators cannot investigate what happened after a problem or attack. To prevent misconfiguration, a few simple practices are important. First, use security rules and limits. These rules control who can access systems and what actions are allowed. For example, a cloud storage bucket can be restricted so only authorized users can open it. Second, scan configurations automatically. Security tools can check cloud settings and detect risky configurations, such as public storage or open network ports. Third, always review before production. Before launching the real system, administrators should check settings carefully to make sure databases, storage, and access permissions are secure. DDoS and availability problems happen when too much traffic hits the system at once. This situation is called a distributed denial of service, or DDoS attack. When this happens, the application may become slow, crash, or even stop working. In cloud environments, another problem is that cloud costs can suddenly increase because the system tries to handle the large amount of traffic. To reduce this risk, cloud platforms use DDoS protection, which blocks fake or harmful traffic before it reaches the application. Another method is using a web application firewall, or WAF, and rate limits. These tools control how many requests each user can send, preventing abuse. Cloud systems can also use autoscaling with limits. Autoscaling adds more resources when traffic increases, but limits and alerts help prevent runaway cloud costs. For example, if a cloud website suddenly receives thousands of fake requests, DDoS protection and WAF can filter the traffic while autoscaling keeps the website running. The key idea is simple: control traffic, protect availability, and prevent cost spikes. Insider threats and human error are common security risks in cloud systems. One problem is when staff get too much access. If many users have administrator rights, one mistake or misuse can affect the whole system. Another issue is that mistakes happen, such as accidental deletion of files or databases. In cloud environments, a small mistake can remove important data. Sometimes small errors can cause big data or system problems, especially when the system is connected to many services. To reduce these risks, organizations can use JIT access, which means just-in-time access. This gives access only when it is needed and removes it afterward. Another protection is approval workflows, where important actions must be approved before they happen, such as deleting a database. Organizations also use audit logs, which record every action so it can be checked later. For example, if someone deletes a cloud storage file by mistake, audit logs can show who performed the action and when it happened. The key idea is simple: limit access, track actions, and reduce human mistakes. To summarize, most cloud breaches begin with identity or configuration mistakes. Reduce risk with least privilege, encryption, private networking, logging, and automation. Practice incident response, and keep keys and patches fresh. Thank you for watching this video. Remember, the cloud is not just technology, it is a new way of delivering services.